So, what I got here is yellow line is the DAC, blue line is the MOSFET. And we're going to check the trigger. When the DAC gets over 5 volts, it's going to drop down to 0. This LED should go off. Yep, there. And we're going to measure the difference between the two, and when the MOSFET's all the way off and when this started dropping. So when the DAC started dropping is right here. When the MOSFET dropped all the way, you can see it has some capacitance, so it takes a little more time to shut off. It's not a straight drop. But we got about 8 right here, and we're in increments of 10 microseconds every square, so that's about 8. And then 10, 20, 30, and then a 5. So it's about 40, 43, 42, around that microseconds. That's pretty good speed. What the circuit's doing is the DAC sets a reference. The DAC sets a reference, and that reference is compared against the voltage coming into here, which is actually going to be coming from a Hall effect sensor. And a Hall effect sensor chip, what it does is it translates amperage straight into a voltage. So a 0 to 5 amp Hall effect sensor is going to make 0 to 5 volts. A 0 to 30 amp Hall effect sensor is going to make 0 to 5 volts, and that's divisible by the 30. Now, these will be switchable, so you can get a little higher. I'm not going up to 30, but you know, if you want to go a little higher than that, that's what I had. So now what's going to happen is, when this is all good and the amperage is lower than the reference voltage, this should be on. And when this is on, these are on. And also solid state relays. When this gets surpassed by the voltage there, then this LED goes off. That's like the condition it's in right now. You should probably, yep, there it turns on. And when that happens, when this is off, then these should be off. That way, if you get an over amperage on something, or a short circuit or something like that, it's going to shut this off as fast as possible to make sure you don't ruin the device under test. So far, the board is coming along beautifully.